Welcome to Civil Engineering for Learners. By Dr.K.Aravinthan. Waste Management. Transfer station. A transfer station is an intermediate station between the final disposal option and the collection point to increase the system's efficiency, as collection vehicles and crew remain closer to routes. If the disposal site is far from the collection area, it is justifiable to have a transfer station, where smaller collection vehicles transfer their loads to larger vehicles, which then haul the waste long distances. In some instances, the transfer station serves as a pre-processing point, where wastes are dewatered, scooped, or compressed. A centralized sorting and recovery of recyclable materials are also carried out at transfer stations. Typical activities at the waste transfer station involve the unloading of garbage trucks, pre-screening and removal of inappropriate items such as automobile batteries, and compacting then reloading onto larger vehicles, including trucks, trains, and barges to their final destination. The unit cost of hauling solid wastes from a collection area to a transfer station and then to a disposal site decreases as the size of the collection vehicle increases. Environmental impacts. Transfer stations make the solid waste collection more efficient and reduce overall transportation costs, air emissions, energy use, truck traffic, and road wear and tear. Modern transfer stations designed to collect wastewater, control spills, and minimize blowing litter, odor, and dust have a minimal impact on the environment. Transfer station operators must monitor the facility grounds for blowing litter, dust, spills, and the presence of vectors such as rodents, insects, or birds. Once a transfer station is permanently closed, operators must remove all waste and residue from the facility and ensure no dumping occurs once the facility is closed. Types: small to medium transfer stations. These are direct discharge stations that provide no intermediate waste storage area. The capacities are generally small, less than 100 tons per day, and medium, 100 to 500 tons per day. Depending on the weather, site aesthetics, and environmental concerns, transfer operations of this size may be located either indoors or outdoors. More complex small transfer stations are usually attended during hours of operation and may include some simple waste and materials processing facilities. B. Large transfer stations. These are designed for heavy commercial use by private and municipal collection vehicles. The typical operational procedure for a larger station is as follows. When collection vehicles arrive at the site, they are checked in for billing, weighed, and directed to the appropriate dumping area. Collection vehicles travel to the dumping area and empty the wastes into a waiting trailer, a pit, or a platform. Capacity. A transfer station should have enough capacity to manage and handle the wastes at the facility throughout its operating life. Designers should also plan adequate space for waste storage and, if necessary, waste processing. Transfer stations are usually designed to have 1.5 to 2 days of storage capacity. Adequate space should also be available for offices, employee facilities, and other facility-related activities. Viability. The cost-effectiveness of a transfer station depends on the distance of the disposal site from the generation area, and a distance of 10 to 15 kilometers is usually the minimum cost-effective distance. The distance between the disposal site and the collection area is one of the principal variables in deciding whether to use a transfer station or haul the solid wastes directly from the collection area to the disposal site. Waste collection system design. After identifying appropriate options for collection, equipment, and transfer, we must examine the various combinations of these elements to define system-wide alternatives for further analysis. Each should be evaluated for its ability to achieve the identified goals of the collection program. The economic analysis will usually be a central focus of the system evaluation. This initial evaluation will lead to several iterations, with the differences between the alternatives under consideration becoming more narrowly focused with each round of evaluations. After comparing the alternative strategies, the various elements like crew and truck requirement, time requirement, and cost involved are calculated. The various formulae used to calculate are as follows. 1. Number of services vehicle load, N. N equals CD/W. C equals vehicle capacity, D equals waste density, and W equals waste generation/residence. 2. Time required to collect one load, E equals NL. L equals loading time/residence, including en route travel. 3. Number of loads crew day, N. The number of loads, N, that each crew can collect in a day can be estimated based on the workday length, T, and the time spent on administration and breaks, T1, time for hauling and other travel, T2, and collection route time, T3. Administrative and break time, T1. T1 equals A plus B. O equals administrative time, for meetings, paperwork, unspecified slack time, and B equals time for breaks and lunch. Hauling and other travel time, T2. T2 equals NHF plus G plus J. N equals number of loads crew day. H equals time to travel to a disposal site, empty truck, and return to route. F equals time to return from site to route. G equals time to travel from staging garage to route, and J equals time to return from disposal site to garage. Time spent on collection route, T3. T3 equals NE, where variables have been previously defined. Length of workday, T. T equals T1 plus T2 plus T3. T is defined by work rules, and equations A through D are solved to find N. 4. Calculation of number of vehicles and crews, K. K equals SF, N, and M. S equals total number of services in the collection area. F equals frequency of collection, numbers week, and M equals number of workdays week. 5. Calculation of annual vehicle and labor costs. Vehicle costs equals depreciation plus maintenance plus consumables plus overhead plus license plus fees plus insurance. Labor costs equals driver's salary plus crew salaries plus fringe benefits plus indirect labor plus supplies plus overhead. Thank you. Happy learning. See you again.